So let's take a look at section 4.2. And at the start of 4.2, you're seeing a sign like this. And I've seen a few like that myself. Let's jump over to here. This is territory that's near and dear to my heart. Vail Pass is in Colorado. And it's quite the fun ride down, especially if it's snow and there's almost whiteout conditions. All right, I'm being a little facetious on that. Has anyone ever seen anything like this, runaway truck ramp? Yeah, we talked about this one? All right, so you're going to find that in some pretty steep parts of the country, not so much in Michigan, although there are some pretty hilly areas up near Boyne City, etc. But the grade that they refer to, that 8% grade, is really this kind of stuff right here. It's how things are changing. So it's kind of a slope. 8% means 8 over 100. That's how much altitude you gain for every 100 feet you move. So, okay. It'd be kind of interesting to figure out, well, how much do we gain in altitude in traveling a distance of 1 mile if we're at an 8% grade? 8% would be pretty make your car unhappy. It'd make you really unhappy if you had to, say, cycle up that. What's that? Find the degree angle. No. Interesting question. 8% and 8 degrees are different. Now, dealing with degrees would be trigonometry, and that's not our task in this course, so we're going to kind of stay away from degrees. But we can figure out how much altitude would change there. So basically, you're going to take 8% of this, so 0.08 times 5,280. And let's just give that a quick little check on our calculator. So it should be 400 and some feet. 0.08 times 5280, 422.4 feet. And that's going to be that side right there. That's how much altitude you'd gain. Now, I think that the question that the book gets at is like, well, wait a minute. You don't drive horizontally and then move up vertically. You're going to drive along this side here. By the way, what is that side called? Does anyone know? What's the length of the longest side there? It's called the hypotenuse. And maybe I'll talk a little bit about that in just a minute. But for now, you're going to gain about 422.4 feet in altitude. The question then is, well, how far is this? And for that, we're going to answer that with a different problem or a different little bit of math here. And let's see. Yeah, go ahead. And that's going to be our Pythagorean theorem here. So the one thing that most people will remember enduringly after they leave their math class is this one right here, the Pythagorean theorem. So what does this little symbol here represent? What am I meaning by this? Yeah, it's a 90-degree angle. So we got a 90-degree angle. If you have a triangle with a 90-degree angle, it's called a right triangle. So Pythagorean theorem applies to right triangles. And in that right triangle, a squared plus b squared equals c squared. Let's see if we can apply that to this thing right here and figure out just how long that side actually is. Now, let's see. Let me just do it here. We're going to take 5,280 feet and square it, and then take 422.4 feet and square it, and that's going to equal, we'll call that c. That's going to equal c squared. And this is certainly something you want to do on your calculator. If you need to borrow a calculator, please come on up and grab one. There you go. I'm going to
phone and the charger right there. So it's like still next to
All right. We'll put the phone there too, though.
Yeah, that's good.
All right. You. That means shukran. Thank you. Thank you. Sorry. All right. So looking good there. Now to plug this one into your calculator most efficiently, open it up and type in the number 5,280, and then just hit the square key. That's midway down on the left. So 5,280 squared plus 422.4 squared. And again, hit the square key. And let's just hit the enter key after that. You get a really big number. Okay, great. But keep in mind that that's equal to c squared. All right. Am I trying to solve for c squared in this problem? No, I'm trying to solve for c. So let me write that big number down here real quick. So I'm going to get, let's see, what, 28,556,821. And then 0.76. Now that's c squared. How do I want to, yeah, if I got c squared, to solve here, I need to take the square root of that number. So the square root of 28,056,821.76 equals c. Now I'm not going to ask that you type that number in. There's a more efficient way to do that. We want to take the square root of this number, so kind of follow along here. This should be the last number in our calculation. If you hit the second key, then the squared key, it pulls up the square root operation. We want to take the square root of that last number. So the easiest way to do that is to hit the second key again, and then the opposite key on the bottom row of your calculator. And what does it put up there for you? It puts up answer. So it says, oh, you want to take the square root of my previous answer. Yes, that's what you want to do. You should get something close to 5,300. So are you able to get that? Yes, sir. Oh, you got yes? Okay, cool. Everyone else able to get that one too? A couple nods.
How do you put answer in?
So it's right there above the opposite key on the bottom right of your calculator. And to get that, you're going to hit the second key and then that opposite key. And that'll pull up the answer for you. Yep. So about 5296.9. By the way, what units should go with this? I mean, something that I would like you to be in a good habit of is taking care of the units. What units should go with this? Should be feet. So let's put feet. Under what conditions would I put feet squared? Alice?
If it's like 2D.
Yeah, if it's two-dimensional, sure. If you're talking about an area somehow. Yeah, perfect. That's when you would use feet squared. But this is just a length, so it's just going to be units of feet. Nice. Nice. Now, there's some kind of, so there's a little bit of practice stuff over here because we're going to be dealing with square roots. So some of the common square roots, square root of 4, I hope you can figure out that's 2. What you're trying to figure out is what do you square to get these numbers? Okay, that's a good question. And what do you square to get 4? All right, that's 2. What do I take the square root of to get a 3? What would I put in here? 9. How about what do I take the square root of to get 36, or to get a 6? I guess I can. Yeah. Guess I kind of gave that one away a little bit. So yeah, it'd be a 6. 36 And square root of 49 would be a 7. What's the square root of 81? Square root of 121? What do you square to get, or what do you take the square root of to get 12? 144. By the way, does anyone know the name for this word? 144. A dozen actually has a name. It's called a gross. A gross. So a dozen is a gross. So, hey, you're smarter than when you came in here. Good deal. Square root of 169 is 13. Square root of 196 is 14. And square root of 225 gives you 15. We're going to play with square roots just a little bit more here. If you had to guess at these without your calculator, just give me the integer part. Like, what would you think the square root of 11 would start with? Yeah, it's got to be 3 something. 3 point, whatever. How about the square root of 78? What's that going to be close to? It's not going to quite be there, but it's going to be close to, it's actually closer to a different one. It's actually closer to 9. How about square root of 99? What's that going to be close to? 10. And square root of 124 is going to be close to 11. Nice. Now, you can practice with these a little bit. Let's just do 1 or 2 of them. I don't think it requires more to be good with finding square roots on your calculator. Let's try and find the square root of 78. So let's clear all that. Second square root, 78. Nice. So about 8.83. And one more. Let's do the square root of 124. The square root of 124 is going to be more or less than 11? Should be more. So I'm getting about 11.13. Actually, we'll round that to 11.14. Nice. Nice. Okay, are you comfortable calculating square roots on your calculator? It's something that comes up reasonably often. Let's keep rolling. So we've kind of already done this. They asked us to look at the Pythagorean theorem here. The Pythagorean theorem is really amazing. And let's talk about Pythagoras himself for just a moment. So let's go over to here. Let's see. There we go. Pythagoras. So quite the mystic. He was in charge of, basically he had like a cult following. And they were really devoted to him. It's hard to know if he discovered the Pythagorean theorem himself or not. And the Pythagorean theorem, at least the numbers that were used in some of the Pythagorean theorems, had been around for a long time before him. So it's unlikely he invented it himself. But we'll find out. There's 2 truths and a lie here. First one, Pythagoras invented a prank cup that if you filled it too much, it would spill all over your hands. Secondly, Pythagoras discovered the theorem that bears his name. Third, the followers of Pythagoras believed that fava beans could contain the souls of the dead since they were flesh-like.
Honestly, I would not be surprised.
Yeah, so 2 truths and a lie. And the lie is that he discovered the Pythagorean theorem. I don't think that happened. But he did have a prank cup, which was kind of funny. And this cutaway shows how it works. There's a little hollow spot inside here, and if you filled up your cup too much, if you're being a little bit greedy at the party, you put too much wine in there, it would create an auto siphon that would actually drain the contents of the whole cup on your hand. So, kind of funny. Who knew that he was a prankster way back when? Any case, let's keep going with some Pythagorean theorem kind of problems. So Let's see. I think we're okay with the square root part here. Let's move over to, let's see, page 456. No, that's the wrong one. Sorry, I went the wrong order. 458. 460. I'm missing my page 460 here for a second. There are some numbers that work out pretty nice with Pythagorean, the Pythagorean theorem. And the one that sticks out in my mind is one that happened to me a bunch of years ago when a friend of mine, Jim Dodge, called me up early on a Saturday morning, woke me up, but he had a good reason. He had rented a plane, wanted to fly us up to near Manistee and go over there to one of the casinos and have some fun. On the way back, he mentioned, oh, we're 5,280 feet in the air, which piqued my interest. Does anyone recognize the number 5,280? It's exactly 1 mile. I started thinking, I'm like, well, I wonder how far you could see if you were 1 mile high. And so it turns into a little bit of a math problem. Now, some trivia that you may not know is that the radius of the Earth is about 3,960 miles. Okay. So that radius is the same if I'm looking here, as far as my eye can see, or if I'm looking here, 3,960. But when I add in that 1 mile, and of course this isn't drawn anywhere near to scale, I actually get a little right triangle problem. So let me draw that for you, and let's see if we can't figure that out. So the right triangle problem turns into this. And again, this is not drawn to scale. So this distance was 3,960. And this distance, well, how far is that going to be? How far is my hypotenuse going to be? The side opposite my right angle. Yeah, that's the 3,960 plus that 1 extra mile for our airplane's height. So 3,961. And let's give this a name. You want to call it H, you want to call it D, what works for you? Height? Okay, we'll call it H. What would the Pythagorean theorem say about this kind of a problem? Can you set up the Pythagorean theorem for us here? So what do we got? Someone want to tell you? What would this look like if I set this up with a Pythagorean theorem?
I did 3960 squared plus 8 squared equals 3961 squared.
Beautiful. So the hypotenuse is always going to be on the one side by itself. And then you're going to sum the other two sides. Sometimes you call these the legs of the triangle. Doesn't matter what you call them. Those two are going to get squared and summed. That should equal 3,961 squared. Okay. Now our goal is to solve for h, right? Let me start by just moving that to the right-hand side and get h squared equals 3961 squared minus 3960 squared. And if you're curious, you're like, well, why don't you square those out? Well, because then I'd have like a really big number that I'd have to write. It'd be like a 9-digit long number or something like that. So I passed on that. Now I want h, not h squared. So what's the last little bit I got to do here? Yeah, I got to take the square root of this. 3961 minus squared minus 3960 squared. The square root of this is not 3961 minus 3960, which would be 1. It's not that. Now the reason I did it this way is because it's going to make it easier for me to put this into my calculator. So let's do that. Actually, I'll do it this way because I think it's a little easier for you to see. Second, square root 3961, and then hit the square key, minus 3960, and hit the square key. And I guess the reason this problem is so memorable is because it worked out so nice. I think if you take the square root of this, or if you just take a look at these two numbers and calculated what you have underneath the radical, you get the square root of 7,921. And that's notable because it worked out pretty even. What'd you guys get? 89. Wow. So if you're 1 mile high on a theoretically very, very flat, perfectly round globe, you should be able to see about 89 miles to the horizon, which is a long ways from what I see. So, yeah, pretty cool. Pretty cool. 89 miles. Now, these numbers that work out nice in the Pythagorean theorem are called Pythagorean triples. Probably the most famous one is this one. 3, 4, and 5 is a Pythagorean triple. So, Pythagorean triples. Would that have 2 P's? Triple, T-I-R-P-P? I think so. Triples. So 3, 4, and 5. And you can see that because 3 squared plus 4 squared equals 5 squared. 9 plus 16 equals 25. That checks. And there's limitless numbers of Pythagorean triples. I think 8, 15, and 17, I think that's one. Let's try it out. 8 squared plus 15 squared equals 17 squared. So it's going to be 64 plus 225 equals 289. Yeah, that checks. But the one I gave you is the highest one that I actually know off the top of my head. And it's because of that problem. Now, these Pythagorean triples are very, very useful. In fact, let's see here. It's how the Egyptians used, or what they used to build the pyramids. So imagine this. You're a contractor. You're being asked to float about 2.5 million 2-ton blocks down the Nile River, and some of them are going to be 20 to 80 tons, which is like 160,000 pounds. Float them at least 8 miles, maybe 600 miles, depending on what quarry you have to use, depending on what stone you have. You're going to do this without a laser sight. Wait a minute, I should probably cue up the music, right? Here we go. There you go. All right. So you're going to do this without a laser sight. You're going to do this without GPS. You're going to form your angles with stretched rope. You're going to make sure that your angles are impeccable so that you don't end up with some sort of sloppy looking pyramid like this. You want the Great Pyramid of Giza, because your boss, your ultimate boss, is a pharaoh who is worshipped like gods, and they would cut body parts off of the armies that they defeated just to keep track of the enemy dead. And if you're really feeling morbid, then you can go look up what body part it was. It wasn't very pretty. So, wow, that's a lot here. And they did this, and they built this structure that was at its peak. It was at 482 feet tall. It's lost some height over the millennia since it was built, but wow, it's just amazing. And they did this. They got their right angles by literally stretching a rope and stretching it and knotting it. Let me see. What's that?
It's kind of like a tape measure.
Yeah, so this was an Egyptian engineer. This person in this picture here is called a harpodinopta. And if you take a look at the way these ropes are knotted, they're knotted in the form of a Pythagorean triple, right? You got sides of length 3, 4, and 5. And when you stretch ropes out like this, then you can determine that, yeah, the angle that's at this corner has to be a right angle. Earlier today, Cora helped me out and Layla helped me out. We did a little right triangle problem ourselves, right? We figured out that, in fact, we can do it out here. Should work out a little bit easier. That one side of our triangle was 12 feet, and then another side was 9 feet. So we had to figure out how far it was. If I was standing at the corner of my board, looking at the back of Cora's chair, how far would that distance be? Well, I should put c, not c squared. And that would be 9 squared plus 12 squared equals c squared. Who can help me out here? What's 9 squared? 81 plus 144, there's our gross again, is 225. What do you get when you take the square root of 225? 15. Cora, did we end up with exactly 15 feet there? Yeah. So pretty good. Now, hats off though to the people who built this pyramid. It's quite the impressive structure. So certainly on my bucket list is to check it out before I kick the bucket. All right, are we okay with the Pythagorean theorem here? There's an application in the book which is kind of interesting, and that goes to this part right over here. Does anyone recognize what's going on with this picture? Say again? Actually, the opposite. Instead of going down, we're going to go up. This is a topographical map. And these are contour lines in that topographical map. Now, they give you a little scale here. So this little legend that this distance is 200 feet. And it looks like we got about that distance here and here. So if both hikers are approaching these different summits from opposite directions, it looks like they're going about the same distance. But that's if you're looking at it from the top down. Looking at it from the top up, or from the side, this profile, you can see, well, wait a minute. It's actually a little different there. So let's see if we can't estimate how far this person had to hike, how far this person had to hike. Who's going to hike further, the first person or the second person? Yeah, it looks like the second person. So let's draw a couple representative triangles here. Both sides here are going to be 200 feet. Well, we got to estimate how much altitude you're gaining for each of these. So let's take kind of a close look. How much altitude does it look like we're gaining in the first person's journey? This one. How much height did you gain? Yeah, about 20 feet. So I'll put in a 20 here. And how about that second person? How far did they move up? Yeah, about 40 feet. Now, if you look at the grade here of this, the grade is just the slope of this. So the grade or the slope is going to be the rise over the run. 20 over 200 is going to give you 1 over 10, or 0.10, 10%. That's the grade of the first one. What do you suppose the grade of the second one's going to be? It's a good question. So we'll do the second one is going to be 40 over 200. 40 divides 40 once, and 40 goes in here 5 times, or 0.20, or 20%. So this one would definitely be a lot more work. A 20% grade, yeah, you'd be most unhappy with that. But our goal is to try and calculate how far they actually had to hike, counting the fact that you're increasing in elevation. So let's figure that out. Someone set up the Pythagorean theorem for me on this one. Max, thank you. What's this going to be? What's the Pythagorean theorem going to be for this distance? We'll call it C. How would I set up the Pythagorean theorem on that one?
200 squared plus 20 squared equals C squared.
Yeah, 200 squared plus 20 squared equals C squared. All right. So it's up to you if you want to do some of this out by hand first. For myself, I find it easier just to plug it in. By the way, this should give me 89. Now in this case, we're eventually going to take the square root on both sides. So you could start out like this. Square root of 200 squared plus 20 squared equals C. Let's see. Square root of 200 squared plus 20 squared. Bam. So you're getting something a little bit more than 200 feet. Did it add a whole lot to his journey that he had to hike up as opposed to just hiking horizontally? Not really. He hiked 200 feet this way. He only gained about a foot in altitude because of that, or not a foot in altitude. He only had to go an extra foot compared to that horizontal distance. So 200 is 0.9 something, 9975. So about 201 feet. Try and do the same thing for the other one. See if that makes a big difference or not, going up at a little steeper angle. I'm guessing that it's not going to make a huge difference, but we'll see. Lenny's, what would the Pythagorean theorem look like for this one over here? What should I set up to start with? Sure. We'll call that C again. So 200 squared plus 40 squared equals C squared. Thank you so much. So square root of that, 200 squared plus 40 squared equals C. Did it make much of a difference for us? Now for myself to type that in, I'm just going to hit the second key, then the enter key, and go back and change that 20 to a 40. So this time you have to go an extra 4 feet as opposed to what you would look at just horizontally. So 200 and, about 204. I'll write it as 203.96. About 203.96. Okay. Looking good on that. Are you comfortable with the Pythagorean theorem? Yes.
Will we round it at 204, or would you?
You know, where exactly I want it rounded, I'll specify where it matters to me. But yeah, I mean, this is really close to 204. So, but as far as where to round it to, I try and tell you when and where I care. All right. If I don't care, then I guess I'm at your mercy wherever you want to round it to. But usually I try and give you a little guidance as to where to round those to. One of the things that you can use the Pythagorean theorem for is finding distances. And unless I'm misinterpreting something, I'm not sure that this problem here works out like I expected it to. I worked it the other day, and I just don't think it's the right triangle here that we're looking for. But in any case, or at least I was expecting a right triangle there. Might be a little bit more accurate. Let's go back to our handout right here. I want to come up with a distance formula for the distance between a couple points. Well, let's take a look here. The points I want to try and find the distance between are these two, right there. I want to find the distance between those 2 points. Does anything strike you about the way I've laid this out? I mean, it's this distance that I'm trying to find right here. Distance between point A and point B. That's the distance I'm looking for. Well, I can think of it in kind of a couple pieces. I think of it as this distance right here. This distance to a point C, that's horizontally, and the distance to a point B, that's vertical. To find that vertical distance, I'm just going to subtract the top coordinate minus the bottom coordinate. That's this right there. Horizontally, I'll take this one minus this one. So that's going to give me the length of that side. Great. But I need a formula for all this stuff. Too bad it's not a Pythagorean theorem problem. Oh, but wait. It is kind of pretty close to a Pythagorean theorem problem. What we can do is call this side A, this side is B, and this side is C. That's actually what we want to calculate all together. So instead of calling that C, let me call that D for distance. So we'll call that D. Now from the Pythagorean theorem, I get A squared plus B squared equals D squared. Okay. Let's actually fill in some of those details. A is just the length of this side between A and C. So you're going to get this whole thing squared, and that whole thing is x2 minus x1. What am I going to square for B? What is B? Nice. y2 minus y1. And that's going to equal d squared. Since I'm running out of room here, I'm going to do 2 things in this last step. First of all, I'm just going to flip-flop the order of this equation. But secondly, I want to get d by itself. How am I going to solve for d on this one?
Something went wrong. Please try again.
No, I think we're okay. How do I solve for d here? What do I have to do? Say I take the square root. So d is going to be the square root of x2 minus x1 squared Nice. Y2 minus Y1 squared. Almost forgot that squared here. Now, one thing I want to be very upfront about is you can't just take the square root of this and add the square root of this. You can't just say, oh, x2 minus x1 plus y2 minus y1. These square roots do not cancel each other out. They just don't. It's probably worth a moment just to kind of show you that, demonstrate it, prove it. In fact, this is a nice counter example to something that I get all the time. So, counter example. And that is, a lot of times people tell me that the square root of a squared plus b squared equals a plus b. Does it? Let me pick a couple friendly values of a and b. So, for instance, let's let a equal 5, b equals 12. Let's check out if 5 squared plus 12 squared is really 5 plus 12. Five squared is 25. I think you guys know that number already. 144. Help me out on the right-hand side. 5 plus 12, 17. Take a look at the square root of 169. Do you get 17? No. You get 13. And what that's showing you is that, in general, that's not equal to that. You just can't take the square root of a sum and simplify it as the sum of the square roots. It just doesn't work that way. Period. A lot more people would pass their algebra classes if that were true. It's not. Sorry, that's not the way the universe was built, so we'll have to work with something else. Okay, but it does give us a way to calculate the distance between a couple points. And to that end, maybe we'll do a little bit of the work here. It says estimate the distance by plotting a couple points on the graph below. If you're creative, you can use a group members page with the same grid to make a good estimate. All right, we're not going to, let's see. So, kind of an interesting problem. Well, maybe not. Kind of a strange problem. They're trying to find where a mouse got trapped underneath your sink or washtub basin, something. And they gave it coordinates. And they gave it coordinates of your access point. So, those coordinates map here. You've got something at the origin 0, 0. You get another point here at 4, negative 2. And then one last point here at 1 and negative 5. So all 3 points of those are in the bottom right quadrant. Let's see if we can find the distance between these 2 points this way. Okay. Let's see how that's going to work out. So let's call this 1, negative 5. I can call that my x1, y1. And then this other point, 4, negative 3, that's going to be my x2 and y2. See if you can't fill in the formula for the distance. X2 minus x1 squared plus y2 minus y1 squared. All right. It should look like this. 4 minus 1 squared plus negative 3 minus negative 5 squared. Tell you what, I'll simplify the first one, you do the second one. That's going to be 3 squared. How about this next one? What do I get when I simplify that? Let's see. Negative 3 minus... That's going to be positive 2. No. Oh, is it negative 2 here? Oh, okay. Thank you. All right, let's fix that. I think this will make it work out a little bit nicer. So a negative 2 there. Okay, yeah, so it's going to be a positive 3. 3 squared, so it's going to be the square root of 18. Yeah, very good. Very good. Should be about 4 point.
It's 4.2462.
Yeah. I'm not gonna make you guys do that many. Nor am I gonna make you break it up like you did, which is the square root of 3 times the square root of 2. 4.2426. That's pretty good. 4.2426. Nice. Nice.
My calculator automatically
Does it? Okay, because I was impressed. Some of you might have calculators that'll play around with it like this. You might recognize that 18 is 9 times 2. What's the square root of 9? 3. So you could also write this as 3 times the square root of 2. That's something I worried about in an algebra class. I'm not going to worry about it for you guys. All right? I mean, if you see that, if you know that, if you're comfortable with it, great. Let's just check it out, though. 3 times the square root of 2. Oh, same thing. Exactly the same thing. So, nice. Okay. Yeah. I guess what threw me off in this one a little bit when I looked at it at home was they said use the Pythagorean theorem to find the exact distance, which will have a square root in it. And I was thinking that this was going to work out to be a nice Pythagorean triple. Also, using the Pythagorean theorem here, we're not exactly using it. We're using the distance formula is the way I see it. So that's what threw me off a little bit here. So it was a distance of about 4.24 feet, or whatever units that they're working with in this particular one. Don't expect to always get even numbers. Those even numbers are nice when you get them, your Pythagorean triples, and what was it, 89, 3,960, and 3,961. That's another Pythagorean triple. Like I said, it's the biggest one I know off the top of my head. That's not a multiple of something smaller. Okay, let's see here. Let's just calculate a couple more distances here to just make sure you're comfortable with these problems. So I'm going to give you a few more points. Let's see. Do I want to, yeah, I guess I'll do it here. Find the distance between negative 2, 5 and negative 2, 8. And then one more between 4, -6, and 10 and let's see, 10 and 4. There we go. If you're watching this later, at some point in the future on YouTube or something, then pause the video and give yourself a chance to try each of these.
Does it matter which direction you show it?
That's a great question. The answer is no. You could call this x1, y1, and this x2, y2, or you could mix those up. This is x1, y1, this is x2, y2. When you calculate the distance, you'll get the same thing either way. So if one way looks easier, then yeah, go for it that way, for sure.
Do you mean to do both 2 negative 2's?
I did. I did mean to do both 2 -2's. There's something I want to show you if you were able to look at this geometrically. Both of these should work out nice and even.
I would expect you to simplify that though.
Oh, yeah, perfect.
Oh, okay. Never mind.
You were right so far.
Yes, there's no speed transfer. Yep.
I just had to do it. I did.
Okay. So let's look at this one. Now, I did choose -2 to be the same in both of these for a reason. But let's actually do the calculation first and then understand the reason second. So as far as the calculation is concerned, we're going to do the square root of -2 minus -2. Be careful, use an extra set of parentheses so that you see the double negative. We need to square that and then add 8 minus 5 squared. What happens when you have -2 minus -2? What are you going to end up with? 0. So you're going to get the square root of 0 squared plus 3 squared, which is the square root of 9, which is 3. If you looked at this geometrically, it'd probably make a lot more sense. So geometrically, well, let's see, I need to go this way. Let's take a look here. We got 5 and 8, -1 and -2. So here's my point at -2 and 5. Here's my point at -2 and 8. The distance between these things is just this distance right here, right? Which is 1, 2, 3 units. 3 units is the distance between those things. So at least our idea of distance matches what we see geometrically here. Yes?
If you do -2 minus 2 and 5 plus 8, it's the same answer. Why is that?
No, it's not. -2 minus 2. 5 plus 8 would be 13.
And
Squared.
-4 would
Yeah,
be
but
nine.
when you square -4, you get a positive 16. So yeah. No, appreciate the question though. Thanks for thinking. The second one. I think the second one also worked out pretty nice. So let's do that one over here. Someone fill this in for me. Izzy.
So I wrote square root of 10 minus 4 squared
Mm-hmm.
plus 4 minus -6.
Mm-hmm.
And that gave me the square root of 6 squared plus 10 squared.
Yeah, I guess this one didn't work out even, did it? 36 and 10, square root of 136. Should be a little bit less than 12, I think, right? What are we getting for that one?
11.66.
Okay, 11.66. Nice. Are you feeling comfortable with the distance formula? Just kind of a heads up here. That gives us a few formulas that we have to deal with. On the one hand, you've got to deal with the Pythagorean theorem. So that's one to take note of. On the other hand, we've used the slope formula. So definitely want to keep that one around. I don't think we're going to be using midpoint, so you can ignore that one for now. With this one. Now, if you're looking at that going, oh my God, those are going to be really confusing. Here's something you can do for yourself on an exam. If you're worried about having these memorized correctly, then at the top of your exam, right when I hand it to you, write down the Pythagorean theorem, write down the slope formula, write down the distance formula before you can forget these things. That way, when I say, oh, you got 5 minutes left, you don't panic, go, was there a plus here, a minus here? By the way, one thing I want to make very clear, when you do these things, when you find the difference of something and then square it, you should always get a positive number for both parts of this. And then you're adding up that positive number. What's underneath here should always be positive. Always. And there's very few times in a math class I'll say always. But this should be always positive. You should not be taking the square root of a negative number. Bad things happen, in this class when you try to take the square root of a negative number. Just don't do it. So, comments or thoughts on distance formula, Pythagorean theorem, etc.? All right. Well, that's it for this section then.